Welcome back, Stella, on this video on the indefinite integrals. Today we are going to see, last time we saw how to integrate x to the n. So today we are going to see how to integrate, we're basically going to see how to integrate uh, any function of the form f of x equals to ax plus b raised to the n, where n is different from 0 and minus 1, and ax plus b is a linear function. Okay, the general formula is, if you are to integrate this, the integral of ax plus b to the n dx is simply equals to 1 on ax plus b, you differentiate it, times ax plus b to the n plus 1 all over n plus 1 plus your constant of integration, where k belongs to a set of real numbers. That's the general formula. So if you are asked to integrate such a function where ax plus b is a linear function and n is different from minus 1 and 0, then this is the formula you should use. It simply equals to 1 all over the derivative of what is inside here, that is ax plus b prime. That's why I wrote prime. So you have to differentiate this, times ax plus b to the n plus 1 all over n plus 1 plus your constant of integration. You understand? So that's the basic formula. So let's get into some exercises. So the exercises I will do will be in your Pure Maths Made Easy, page 329. Exercise 17.2. That is, it's on page 329. Pure Math Made Easy. Pure Math Made Easy. Okay, we are going to do the first one. The first one, we're asked to integrate f of x, which is equals to 3x to the fourth. Here, basically, you can decide to develop this and use the first formula, that is the integral of x to the n. But let's try to integrate this using this formula. Using the formula, the integral of f of x dx will be simply equals to what? The formula says 1 all over what? The derivative. This is a linear function, and this 4 is different from minus 1. So we are already in this case. So 3x prime times what? 3x to the 4 plus 1 all over 4 plus 1 plus our constant k1 of integration. This will be equals to what? This gives what? The derivative of this is what? Simply 3. Simply 3. So here we're going to have 5. So 3 times 5, this will be 15. 15x, 3x to the what? 3x to the 5. You understand? So this will be simply equals to 3 to the 5th all over 15 times what? Times x to the 5th plus our constant of integration. Plus our constant. Never forget the constant of integration, because here we're dealing with primitives, not definite integrals. So the next example, we're going to do question 3. So you just go to this exercise and you will see where I took the examples. So we are to integrate 3 f of x equals to 2 minus x to the what? To the half. So the first thing we have to check, when we look at this inside, it is of the form ax plus b. It's a linear function. This top is different from 0 and minus 1, so we can use our formula. So let's proceed to the integral. The integral of f of x dx will be simply equals to, let's apply our formula. This will be equals to 1 all over what? This prime will be equals to 2 minus x prime times what? Times 2 minus x, pardon, hey, be very careful. I made a small error here. The integral of f of x dx will be equals to what? the integral, let's first write this integral of 2 minus x to the half. This will be simply equals to 3 integral of what? 2 minus x to the half. So dx, pardon, dx. So we are to integrate this. We shall just use our formula because this is a linear function and this is different from 0 and minus 1. So 3 times 1 all over this 3 times the integral of this. This will be equals to 2 minus x prime times what? 2 minus x to the half plus 1 all over a half plus 1 plus our constant of integration. That's it. Okay, let me go to the next page. So this will be equals to 3 times what? The derivative of 2 minus x is simply equals to what? Minus 1 times 2 minus x. A half plus 1 is simply 3 on 2. This will be 3 on 2 all over 3 on 2. So this will be equals to minus 3 times 2 on 3 times 2 minus x to the 3 on 2. So this 3 goes and we have the integral of f of x dx, which is equals to minus 2 minus x to the 3 on 2 plus our constant of integration, don't forget it, plus k1 plus k1. I hope it was k1. What was the constant I used? K1. Okay. Wait, let me see something. Okay, I use K2 instead. So this K2, K2, K2. Okay, where K2 belongs to the set of real number. Let's do the next one. Let me do the next one. Let's do question 8 of that exercise, where f of x is given to be the square root of 2 minus x plus 1 all over the square root of 2 minus x minus 3 all over 2 minus x cubed. Okay, I can write back this as this is equals to 2 minus x to the half plus 2 minus x to the minus a half minus 3 into 2 minus x to the minus 3. Okay, now we can proceed to integration. So the integral of f of x dx will be equals to, first write everything, first pass the integral all through first. So don't just start integrating, you should first pass your integral. So our half will be equals to the integral of 2 minus x to the half, 2 minus x to the half dx plus the integral of 2 minus x to the minus a half dx minus 3 integral of what? 2 minus x to the minus 3 dx. So now this resembles our condition. So this is a linear function different from 0 and minus 1, and it's the same thing everywhere. So this will be equals to, we apply our formula, 1 all over 2 minus x prime times 2 minus x to the half plus 1 all over a half plus 1 plus, I integrate this. This will be equals to 1 all over 2 minus x prime times what? 2 minus x to the minus a half plus 1 all over a minus a half plus 1 plus, minus 3 times, I integrate this will be 1 all over 2 minus x prime times 2 minus x to the minus 3 plus 1 all over minus 3 plus 1. Don't forget, plus our constant of integration, k3. Okay, let's simplify things. This will be equals to, the derivative of this is simply minus 1. You understand? So this will be equals to minus 1. Let me simplify things quickly. This half plus this will give what? 3 on 2. Since it is on 1, we are going to have minus 2 on the 3. That's it. Okay, let me go gradually. This will give, the derivative of this will give what? Minus 1. So this will be minus 1 times what? Because this is 1 on minus 1, which is minus 1. So I will have, this will give me this. This bottom will be 3 on 2 times 2 on 3 times 2 minus x to the what? To the 3 on 2 plus this will give minus 1. Minus 1 times what? This bottom, minus half plus 1, minus half plus 1 gives a half. So since it is on 1, since it is 1 on a half, we are going to have times 2 minus x to the what? To the half, because half plus 1 is a half. So minus 3 times what? This times minus 1 times minus 1, and this one we're going to have here minus 2. You understand? So times minus 1 on 2, times again this one, this is 2 minus x to the what? To the minus 2 plus our constant k3. So let's simplify things. It implies the integral of f of x dx will be equals to what? This gives minus 2 on 3, 2 minus x to the 3 on 2. This will give minus 2, 2 minus x to the half. This will give, this is minus 3 times this gives 3 times this. We are going to have minus 3 on 2 into 2 minus x to the minus 2 plus the constant of integration k3. So that's our integral. That's our primitive we just got. That's our the indefinite integral. So that was all for this part, integral of functions of the form ax plus b, integrals of functions of the form, let me go back to the slide, integrals of the functions of the form, or is it even functions of the form ax plus b raised to the n, where n is different from 0 and minus 1. When n will be equals to minus 1, we're going to have 1 on ax plus b. Integrating this is different from this, so be very careful. When n equals to 0, we simply have ax plus b to the 0, which is equals to what? 1. The integral of 1 is what? The integral of 1 is simply x. Dx plus is simply x plus the constant of integration. So that was all for this video. Try to go through the video and remember the formula on how to integrate this. We're going to let's catch ourselves in the next video, where we are basically going to enter into how to integrate some basic trigonometric function. So see you in the next video.